Good day. This is Dr. Craig Lowe. We're going to be talking about a very interesting area of orthopedics called functional biomechanics. And we're going to look at the inside of the world of functional biomechanics from the physician perspective. The first thing that we're going to look at is the anatomy. We break the anatomy down into 4 different sections, 2 in the forefoot and 2 in the rear foot. Each of them have a unique mechanical perspective and function. When we look at cyclic load, we look at things in both static and dynamic components. Static is standing, dynamic is in movement. And we look at both of these because the foot and limb functions differently when it's in motion than when it's not. Now we're going to look at the conception of 3D load mechanics from the hip unto the foot. The first plane of the body that we're going to look at is the lateral plane. The next plane of the body that we're going to look at is the transverse plane, which is the floor surface, as if you're looking from the head down to the feet. This next area has to do with the ankle joint axis between the articulation of the talus, the fibula, and the tibia. This is a frontal plane view of the subtalar joint. Notice the difference in articulation between the head of the talus and the body of the navicular. It is more oblique in the pronated foot than it is in the supinated foot. This is a lateral view of the foot showing the oblique and longitudinal axis of the mid-tarsal joint. The more oblique the axis is, the more pronated the foot is. And it's also being viewed on the transverse plane. This next area has to do with the transverse plane view of the oblique axis of the first ray. This is extremely important. This denotes mid-tarsal joint function as well as first ray function. And the first ray is vital in the development of propulsion in the propulsive phase of the gait cycle. This very next important area has to do with the hypermobility of the first ray and the positioning of the sesamoids, which are underneath the first metatarsal head, which also denotes frontal plane rotation of the first metatarsal in the development of hallux abductus and hallux abducto-valgus deformities. The more rotation that there is, the more oblique the mid-tarsal joint axis is, the more pronation of the foot, which leads to hypermobility of the first ray and exposure of cartilage to compressive forces. This next section has to do with Wolff's Law, which has to deal with adaptive changes that occur to bone as cyclic loads change within the load-bearing structures of the body. And this is the process that leads to osteoporosis, osteopenia, degenerative arthritis, acceleration of collagen vascular diseases. And this can be mitigated by bioengineered orthotics. So the goal is to minimize the amount of stress on bone structures and allow the balance of load to be uniform so that bone adapts properly. The last but most important area is what can you do to reduce shock loading besides the use of bioengineered orthotics to align joints, and that is through kinetic footwear. And we use a particular shoe called a Spira kinetic shoe made by Spira in the United States. And this particular shoe offloads 97% of reactive ground force on man-made surfaces, asphalt, concrete, and tile.